Hello, and welcome to episode 10 of taking apart a Monroe Model K mechanical calculator. This is a special episode, not only because it is episode 10, but because we actually are going to talk about taper pins. I've looked at the parts that are remaining, and we can't really go that much further without dealing with taper pins and their removal. So I'm going to take apart the intermediate axle, the intermediate gear axle. Basically, it looks like all the parts can come off this way. It's held on, these gears over here on the end are held on by a screw at the end, but then we're going to get a taper pin. So let's start a new bag, and this is going to be bag 12. So bag 12, 77339. Let's go ahead and unscrew this. I think I'll need a bigger bit. Can I use the really big screwdriver? Yes. Now I think I'm going to have to hold on to the other end with something. Okay, there we go. Okay, it comes right out. Are there any pieces in between? So there is a gear, and the gear has a shoulder on it, which faces that way. Then there is a spacer, and then this double gear assembly, and then this screw with shoulder. The screw is 836, and its length probably doesn't matter too much. Total length 0.951, and that goes in bag 12 along with this thing. The spacer, whose outer diameter is 0.881 and whose thickness is 0.064, and then this gear, which will just measure the outer diameter between the teeth, is 1.381, and its total thickness is 0.123. Okay, so the taper pin. So we can see that this taper pin goes all the way through. It sticks out on the top, and it's got a kind of a rounded top, and there's a hole on the other side. Let's see if I can, so there's a hole on the other side right here. And the taper pin is in there somewhere. So before we talk about removing the taper pin from here, let's take a look at some taper pins. So this is a set of taper pins. Taper pins have a standard slope, and they come in various sizes. This is called a number 2, number 3, number 4, and a number 5. And the higher the number, the smaller the taper pins. So these are small taper pins, and these are number 2 taper pins, which are significantly larger. And when you insert a taper pin, you basically drill an undersized hole through both parts, and then you use one of these. This is a taper pin reamer. It is tapered in the same way as the taper pins are, and you use basically a hand tool, just like a tap, and you tighten the tool on the reamer, and then you just ream it out by hand to the right size. Then you put the taper pin in and give it a few gentle whacks with a little hammer, and you're done. Those two parts are not going to separate. Now, removing a taper pin, it seems that it should just be the opposite. So you would take some sort of a punch. I have a little punch over here. Punch. Focus. I think you're focused. A punch, and you just go to the small end of the taper pin. Obviously, you shouldn't do this on the large end. You go to the small end of the taper pin, and you just give it a couple of taps, and it comes right out. Easier said than done, especially when you're dealing with taper pins that have been sitting in there for 80 or 90 years. So, what I have found usually works, and I may not have to do that on these because these parts appear to have been very well kept, well maintained. They're not dirty at all. There's no visible rust anywhere. Usually what I do is I go outside and I get some penetrating lubricant and I get a heat gun. And a heat gun is just sort of like a hair dryer. You could probably even use a hair dryer, but there's a special tool called a heat gun that's used in electronics. And you just plug it in and you blow hot air at this. And what that will do is that will expand the metal, ever so slightly, of course. Then what you do is you spray the part with penetrating lubricant. And it'll smoke a little bit, but it's not going to get set on fire or anything. So this is why you want to do this outside. So you just spray it and let the smoke dissipate. Spray it some more until there's no more smoke. And that basically indicates that the part has cooled down. Then what you do is you take the heat gun and you heat it all up again until it looks like all the lubricant is evaporated. And then you hit it again with a spray of lubricant. And you just keep doing that several times. So this is this heat cooling cycle. The theory behind this is that the lubricant can then penetrate into the very, very tiny space between the pin and the hole. The hole through both parts. Then you should be able to tap it out. Now, tapping it out requires that you support the part from underneath, and you want to orient the part so that the small end of the taper pin is up. And determining the large end and the small end of the taper pin is a pain in and of itself, because usually, or often, the taper pin will actually be ground off at both tips, and then actually measuring it with a caliper is extremely difficult. However, there are some hints. If you're lucky and the taper pin is not ground off, the large end of a taper pin, so let me just get a number 2 taper pin so that I can show this. Let's see. So the large end of a taper pin is kind of rounded. The short end of a taper pin is not. It's flat. So this is useful because if you do look at this taper pin, you can see that that end is rounded, which means that that must be the large end, which means that we're going to tap on the small end. So the next thing that you have to do is you have to measure the diameter of the part that the taper pin is holding on to. This one is 0.567. And you need to, and unfortunately there's no standard tool to do this, do not use a vise. Please do not use a vise because you'll just end up damaging your part. You want to support it with something round. So here I have a half circle that I've milled out of a block of aluminum, and I have them at different sizes. So different sizes, very, very small. And in addition, I have a slot running down the length. It doesn't have to run all the way down the length, but this is so that the pin can fit right into the slot so that as you bang on the pin will go down into the slot. So the closer the diameter you get, the better. But 0.567 is kind of a funny little, funny kind of a measurement. So instead, I'm just going to use the closest one, which I think is 0.625. And then what you do is you support it like that. Well, okay, so in this thing, we have this rod, which actually fits through a hole inside here. And you can't pull it out, but you can tap it out. This is not a taper pin. This is just a straight rod. So what I'm going to do is, let me just support the other end with something. And then I'm just going to give it a gentle tap. Okay, that's not so gentle, is it? But it should come out soon. Let's see. There we go. And then I should just be able to pull it out with something. I'll tap it out with a longer punch. There we go. And it just comes right out. It is 0.124, 0.125 in diameter. And it is 0.1, it's 1.695. So that goes in bag 12. Okay, so now that that's out of the way, and it's, let's see. I guess it was important that there is actually a slot-looking thing over here, so the pin actually went down this way and not up that way. Don't know if it matters, but okay, so the taper pin. What I like to do is I like to measure how far the taper pin is sitting out of the part right now, and it says 0.113. If I measure it again, I will probably get a slightly different measurement, 0.111. The point is that I want to see if I'm making any progress. So, now remember that this was done without heat. So I'm going to support the one end, put the other end here, and then I'm going to, let's see, yeah, this one. See, this punch is actually the same thing as this punch. I just cut it off to make it slightly bigger. But and the danger with using a thinner punch than the hole is that the punch will just deform. So let me see. Yeah, I don't know if it's such a good idea to use that punch. So I'm going to use this punch and just see what happens. Comes right out. Okay, so there's the taper pin. Now, in terms of the actual size of the taper pin, we can try to match it up. Of course, these taper pins are of standard slope. They all have the same slope, which, don't quote me on this because I'm just trying to remember this. I think it's, yeah, I don't even know. But if I try to match up the size, it looks kind of like it's not a number 5. It looks like it's a number 4. Whoops. In fact, I should be able to take one of these number 4s and see if it actually goes through. So one end is the big end. Okay. So it actually does look like it goes in somewhat, but because this is the large end, I really wanted the large end to go in a little more. So maybe it is not a number 4. Maybe it is actually a number 5 pin. So here's a number 5 pin, and I'm just looking at it. Yeah, it looks a little closer. So if I put the number 5 pin in, nope, it's definitely not a number 5 pin. All right, so clearly they had like something in between a number 4 and a number 5. So I guess what I would do is I would use obviously the number 4 taper pin. I would put it in, and then I would have to grind off the top end, which is unfortunate because then it doesn't leave that nice indication that this is the large end. So, but at least I could leave a bit of the large end protruding. So, taper pin, bag 12. And now, we should just be able to remove this part. Sometimes it takes a little bit of persuasion because it's been sitting in the same position for so long. So I'm just going to use my locking pliers to gently turn it. And sometimes it takes even more persuasion than that. Yeah. Sometimes the only thing you can really do, unfortunately, is bang on it. So yeah, that's not going to work. The idea is that you would want to somehow bang on this while just holding it like this and essentially hoping that you don't damage any of the parts. So let's see what we can do. Yeah, I don't have any leverage. Let's try this. Yeah, I don't know. Well, okay. So, all right, I'm kind of at a loss as to what to do at this point. Could I maybe bang on this, maybe? To just sort of loosen it a little bit. No, that doesn't really work either. So this is probably a place that penetrating lubricant might work. So what I'm going to do is I'm going to hit this with some penetrating lubricant. I'm just going to wait a little while, and then I'll come back and see if we can remove this. Let's see. Oh, well, you know what? This actually isn't completely round, so I might actually be able to turn it if I hold on to it from one side, like that. And then, of course, I'm going to have to hold on to the other side somehow and just try to turn it. Nope, it's not gonna loosen. Okay, so I'm gonna end the video here. So actually, you know what? It did turn a little bit. Maybe there's hope. Let's see. Yeah, I don't want to damage the part. All right, so I'm going to end it over here. When I come back, hopefully the lubricating or penetrating lubricant has penetrated inside and made it a little bit easier to remove this part. Unfortunately, the only taper pin manipulation that I've been able to show you was on this part where it was extremely easy to take the taper pin out. We're probably not going to get to the point where we have to drill taper pins out. That's really, really bad. But unfortunately, sometimes it has to be done, and then you basically have to ream it out and put in a larger taper pin. And then it's good for the next 80 or 90 years. So with that, I think we'll end this episode. So see you next time. Bye.